Hello everyone, welcome again. Today we are together for a practical workshop session on design eco-friendly packaging, sustainable menu and value-added product prototypes to support food waste reduction. First, I would like to give you some theoretical information about our topic. Then, we will conduct a case study shaped by the different perspectives of three different fields of expertise. Finally, we will make the information we obtained from this study more concrete numerically using an Excel spreadsheet. Let's begin. Our learning objectives and aim that today, multidisciplinary collaboration to comprehend how different disciplines such as food engineering, interior design, and educational sciences jointly create value within an ecosystem for sustainable food system design. Technical analysis and LCA, life cycle assessment methodology, to be able to numerically analyze carbon and water footprint savings in packaging and food production processing using the LCA methodology. Upcycling strategies to explain the process of transforming food waste, stale bread, fruit peels, whey, etc. into low impact but high value strategic raw materials. Sustainable menu design to develop menu models that minimize operational waste and provide high nutrition density using the root to stalk approach. And finally, behavioral change and education to evaluate the impact of digital tracking system and interactive living lab special design on sustainability literacy and student behavior. Okay, today, first of all, we will discuss how to reimagine our food system, not just the production lines, but as a living ecosystem. While food engineering has traditionally been defined within the limits of quality control and safe production, this role is undergoing a profound transformation today. As defined within the Green Comp framework, a food engineer has now become a sustainability designer who aims to create environmental value from the very beginning of the production line. In this presentation, we will examine how waste can be transformed into a strategic raw material and how we can minimize carbon and water footprints through multidisciplinary collaboration. Welcome to a circular economy journey that can serve as a model. Okay, continue. Here. Yes, the numerical foundation of sustainability is formed by life cycle assessment, or LCA. This method allows us to analyze the entire process of a product from raw material extraction to final disposal, from cradle to grave. For a food engineer, LCA is the clearest way to understand a product's environmental profile. Comparisons made through carbon and water footprint data are the cornerstones of green innovation. For example, choosing cornstarch-based PLA or biopolymers derived from agricultural waste instead of traditional petroleum-based plastic is not just a waste management move, but a strategic stance against fossil fuel dependency. Through this analysis, we can prove with data how packaging will align with the circular economy without losing its protective properties. Packaging is not just the shell for the product, but an integral part of its environmental burden. Data shows that using 100% recycled cardboard can reduce the carbon footprint by up to 60% compared to virgin plastics. Even more striking, producing 1 ton of recycled paper saves 17 trees and 26,000 liters of water. Reusable glass or stainless steel system initially have a high carbon load but reach an environmental break-even point after 15 to 20 uses. After this threshold, waste production decreases by 80%. Furthermore, examples such as maculum-based packaging, which requires 90% less energy to produce and biodegrades with 45 days, or vegetable-based links that reduce work emission by 70%, demonstrate the power of design decision. Numbers are incredible. A significant portion of food waste stems from inefficient preparation process in the kitchen. The root-to-stalk approach stops this waste at the source by incorporating parts traditionally discarded, such as broccoli stalks or watermelon greens, into the menu as nutrition components. Engineering intervenes here by calculating the water and carbon cost of each serving, enabling the design of low-impact but high-nutrition menus. Using celery stalks for vegetable stocks, upcycling peels into pickles, or producing vegetable rice from broccoli stalks are concrete examples of kitchen innovation. Additionally, reflecting water consumption per serving liters per portion on menus to educate consumers is a critical step in creating awareness. Upcycling not only reduces waste but also leads to significant emission savings. Looking at concrete figures, upcycling 1 kilogram of stale bread into flour prevents 106 kilogram of carbon dioxide emission from being released into the atmosphere. The transformation of citrus peels saves 0.85 kilogram of carbon dioxide emission while effectively recovering 250 liters of virtual water back into the system. Valorizing whey for protein powder means of saving of 150 kilogram of carbon dioxide emission per ton and prevents a pollution load equivalent to the daily biochemical oxygen demand of 2,500 people from entering water resources. Biofuel production from coffee grounds provides a saving of 0.55 kilogram of carbon dioxide emission per kilogram. This data proves that waste is not lost calories, but a strategic raw material. Now we have a case study. Name is Circular Campus Canteen, transforming university dining into an interactive learning and production space through sustainable innovation. Let's summarize it. As we began remaining our canteen as a living lab, we were faced with a massive daily organic load of 50 kilograms. The current situation was like a fortress of plastic and single-use culture. our vision was clear: to stop viewing this waste as a lost calories and reclassify it as a strategic raw material. By setting up small production units to transform stale bread into upcycle and flour and surplus way into probiotic drinks, we aim to turn the canteen from a passive consumption area into an active center of production and learning. Now, my friends, picture a campus cafeteria in your imagination. But wait, not one of those bustling places, the kind filled with single-use plastics. Not at all. This is a place where waste isn't seen as a problem, but as a strategic raw material. In fact, it's a cafeteria where the machines that transform food aren't hidden, but rather displayed behind glass, a living laboratory where you can see on giant screens how much carbon your meal saves at that very moment. Today, we are going to examine how those sustainability ideas that look great on paper actually come to life in the chaos of a campus cafeteria. Our case study name is Circular Campus Cafeteria. Our goal isn't just to understand what's being done, but to figure out how it's being done. We have three characters. Aisha, as a food engineer, analytical, focus on technical data safety. Yokai, interior designer, focus on aesthetic, material cycles, and spatial flow. Julia, as a teacher, focus on behavioral change, communication, and awareness. So, Aisha said, my friends, we are facing a massive daily organic load of 50 kilograms. My solution is clear. We must stop viewing this waste as lost calories and reclassify it as a strategic raw material. Yokai, I'm looking at all through the language of the space. The canteen currently feels like a fortress of plastic and single-use culture. My idea is to manufacture canteen furniture from agricultural waste found on campus, such as hazelnut shell composites. Ilya, as a teacher, technical and architectural solutions are great, but we are forgetting the human factor. Without creating awareness, no one will drink Aisha's beverage and no one will use Gökay's sorting solution. Station. My proposal is to turn the canteen into an interactive learning space. So, my friend, how did a food engineer, an interior designer, and the educator come together to solve a huge problem like waste? Where did they disagree? Where did they clash? And how did they eventually establish a functioning system? We'll examine this step by step. And please do it this conversation in your mind. It all begins with a very concrete problem. A full 50 kilograms of organic waste per day. Yes, that's the strategic point. Ayşe, the food engineer in the case study, doesn't call it garbage. She doesn't call it lost calories either. She call it strategic raw material. Just this choice of word changes the whole perspective. This is essentially the essence of the circular economy, reframing the problem as an opportunity. This third point is the key takeaway from the very beginning of the project. But what's really interesting, in fact, that this idea couldn't have come from just one person and been implemented alone. Our case study presents use with three different characters. On one hand, there is Ayşe, as you know, food engineer. Other hand, Gökay, the interior designer, and finally, Julia, the teacher, who will explain the school system to people and focus on changing their behavior. The engineer's efficiency clashes with the architect's aesthetic, and the educator ideals clash with the realities on the ground. What made this project different? Let's start from the very basics, the technical part. Let's look at what Ayşe did with that strategic raw material she had. Ayşe's approach is extremely practical. Instead of sending the waste elsewhere, she proposes setting up a small production unit right inside the canteen. This eliminates logistic and cost and carbon footprint. Ayşe focuses on two main processes. First, stale bread. Instead of throwing away leftover bread from the kitchen, she puts it through controlled fermentation and drying process and transforming it into numbers flour for new bakery products. That's exactly it. This isn't reselling as we know. It's more than that, as you know, absolutely upcycling. We say that you are creating a brand new product with higher value from a low value based product, like producing the raw material for a fresh cracker from stale bread. What was the second process? The second process is we take this liquid, which is normally poured down the sink and causes water pollution, and process it to transform it into biologically rich, functional drinks. The ideas sound great, but projects like this require numbers of convinced manager or investor. So, as a good idea isn't enough. They'll ask how much it actually saves and what's the tangible environmental impact of this transformation. That's where the project is the strongest. When you convert 1 kilogram of waste bread into flour, you prevent approximately 105 kilograms of carbon dioxide emission from being released into the atmosphere. That's a very significant figure. This includes not only the energy lost in production of the bread, but also the methane gas it would release while decomposing in landfill. The entire cycle is taken into account. Why it is even more striking. Recycling one ton saves approximately 150 kilograms of carbon dioxide. But the truly incredible thing is this. This action prevents water pollution equivalent to the daily biochemical oxygen needs of 2,500 people. It's like preventing a river or lake from drying. The numbers are truly impressive, but they are invisible numbers. A student sitting in the cafeteria doesn't feel them. The immediate through is a production unit means noise. Maybe the smell means industrial machinery. Even you have the best data in the world, if the cafeteria resembles a factory, nobody wants to sit there. Of course, how does this solve this problem of aesthetic and comfort? This is precisely the question that became the first major point of conflict and turning point into project. Because when interior designer Gökay sees Ayşe's technical plans, he reacts exactly as you say. According to the notes in the case study, our case study, he describes the existing canteen as a bastion of plastic and single-use culture and proposes a competitive transformation. But he absolutely does not want Ayşe's noisy, ugly metal box to be at the heart of the transformation. The great battle that has lasted for a century. Functionality or aesthetic. The eternal struggle of engineer and designer. So, who wins? What they did. That's where the genius of the project lies. Nobody wins because they transform the conflict into collaboration. Gyokai's initial reaction is, we absolutely must hide this machine. We must conceal it behind a wall. A very natural reaction. But this discussion leads them to a much more creative solution. The solution isn't to hide the production unit. On the contrary, it's to make the most visible, the most central part of the space, to turn into a showcase. In other words, they decide to display something they feared would be ugly and noisy, like a jewel. And this idea elevates the project from the ordinary to a higher level. It transforms that ugly machine into a modern art installation surrounded by soundproof glass and specially designed lighting. Thus, Ayşe's technical process becomes visible and transparent. Gökay's aesthetic concerns are addressed, and most importantly, the moment when waste is transformed into value becomes the main attraction of the canteen. This was truly a turning point. Gökay incorporates the idea of circularity into every detail of the space. For example, he ensures that the tables and chairs in the cafeteria are made from biocomposite materials derived from hazelnut shells, which are compost waste themselves. So even the chair you sit on make you feel like you are part of that cycle. He also takes the foul-smelling trash cans, usually hidden away at the back, and transforms them into a central waste disposal station with stylish design, color-coded sorting system, which he calls a recycling wall. Let's see what we have now. We have a fantastic technical infrastructure. It transforms waste into a product. There is a brilliant architectural solution showcasing these techniques. Everything looks perfect, but now, the biggest challenge comes to mind. We are talking about students, young people aged 19, 20, 21. How do you get them to care about or even notice such as meticulously designed system? This is the second major challenge of the project, and that's where teacher Hülya comes in. Her task is to make this wonderful infrastructure meaningful for the students. She aims to transform the canteen from a passive dining area into an interactive learning space. But she doesn't do this with boring posters or brochures. She uses much smarter methods. For example, she puts small, understandable symbols next to each dish on the menu. These symbols show the water footprint of that dish. So you instantly see how much water was used to produce that meatball on your plate. Exactly. This is a very powerful way to compress the environmental cost of your choice. Another suggestion is to use technology. She is creating a system where students can track their own waste savings installed through QR codes on the tables and giant screens in the cafeteria. So, yes, they can see the total carbon saving across the cafeteria leave. She makes the process a bit gamified and creates a feeling of immediate satisfaction. This idea of transparency is good, but it also raises questions. What if after a while sustainability fatigues? It's interesting content. There is a risk of creating a problem. I mean, numbers, data, warnings everywhere. Wouldn't people start ignoring this information overloaded after a while? Food engineer Ayşe has an objection to Hülya's brilliant ideas in her study. She says, If the upcycled crackers I produce taste bad or the beverage packaging doesn't inspire confidence, then your digital screens or QR codes are useless. So they argued that technically quality, taste, and food safety should come before all these educational efforts. A valid point. No one wants to eat bad food just because it's green. And that's where the project's most mature and balanced point emerges. They understand that none of these three pillars are sufficient on their own, nor is educational awareness sufficient on its own. The system Hülya has created is the perfect tool to tell the story of Ayşe's products. Ayşe's delicious and safe products ensure that Hülya's story is full of substance. Gökay's design makes the whole experience enjoyable and comfortable. Exactly. When these three support each other, the system truly begins to work. When all these conflicts, compromise, and brilliant ideas come together, the living laboratory we mentioned emerges. So, how does this laboratory, I ask you, work in practice? Think of it. Let's imagine a scheme where a student describes a typical lunch experience in that cafeteria. You enter the cafeteria as a student. While ordering, you see Ayşe's upcycling chips made from that day's stale bread on the menu, and out of curiosity, you buy some. The chair you are sitting on is a unique chair with a story behind the texture, designed by Gökay using hazelnut shells, a campus-based product. Right opposite you, in the heart of the canteen, in the glasses display case we mentioned earlier. Inside, you can watch live process of whey being transformed into a probiotic drink. But this isn't an industrial spectacle. It's more like an artistic show. Almost an artistic show illuminated with the Gökay's touch. So you can watch how the flour for the chips you are eating and drink you are about to have are made. This transparency creates incredible trust. So, my friend, this brings us to one final thought. How can this model be adapted outside of campus? This is your homework. For example, to the office building where you eat every day, a hospital, or a city square, look around you. What strategic raw materials are currently considered waste but cloud actually became part of this cycle? Now we need to find funding and investors for Hülya''s, Gökay and Ayşe's project. We will use our Excel spreadsheet for this and add this data to our business plan. The first page of our example template you can find in our supplementary document is where technical data turns into strategic decision. Here, the food engineers enter the daily amounts of waste generated in the canteen into the system. The system automatically converts these entries into carbon and water-saving data. For example, we can clearly see the saving potential of a daily organic load of 50 kilograms here. For example, weekly totals are automatically calculated according to the canteen's operational days. While this tool numerically proves how waste is transformed into a raw material instead of going to the trash, it also provides direct data for the school. Silbret daily amount uh, for weight-free pills, 6 weigh kilogram 3. Look at these cells, please. Coffee, 5 kilograms daily amount, and spent grain, 2 kilograms. Weekly total 100 kilogram waste we have. You can see carbon dioxide emission savings factor, water savings factor, daily total carbon dioxide emission savings, and daily total water savings, as you see. In second page, places our material choices on a scientific foundation. This section, which calculates the environmental break-even point of packaging, shows the impact of abandoning single-use plastic as a percentage. It also includes the carbon equivalence in furniture production of side streams that can be collected on campus, such as hazelnuts or eggshells. Eggshells have mycelium. Carbon emission reduction you can find here. Substitutional material you can find here. As you see, for instance, converting 1 kilogram of eggshells into calcium powder and using it as a bioplastic filler reduces the carbon emission by 45% compared to fossil-based alternatives. The saving of 0.65 kilogram of carbon dioxide emission. In third page, you can find our characters, our individual responsibility, joint requests expected from others, and data storytelling goal. This is our scenarios summary. And our dashboards, the final Excel sheet shows the big picture of the project. Here we track how close we are to the annual goals of 1,050 kilogram of carbon dioxide emission savings and also 500,000 liters of virtual water recovery. Our dashboard is here. Data is updated in real time and the target realization rate is reflected as a percentage. This section is not just a calculation sheet, but also a visual communication tool designed to make success concrete for students and for you. Mapping such as the number of trees saved or prevented vehicle driving distance increase the motivation of the entire campus community by storytelling the data. And you can make charts or graphics with this equation and with this number. You can find this Excel sheets, as I said before, our supplementary document. And you can calculate different simulation and number. And you can see the in dashboard the final calculation. My friends, yes, my friends, thank you for listening.